Okay, thank you for the introduction. Yeah, so I'm Matt. I'm the founder of Polaris. We were spun out of the George Washington University. And I want to talk to you today about our DC voltage regulator technology. And so virtually all modern semiconductor chips rely on DC voltage regulators for their source of reliable, stable DC power. And in next generation electronic systems, there are 4 key requirements for next generation voltage regulators. So number 1, they should be as small and lightweight as possible. They should also generate a minimum amount of electrical noise, and that's particularly important in sensitive cutting-edge electronic systems. They should be high efficiency. That's to minimize heating and power consumption. And they should also be able to withstand harsh environments such as high temperature, or for space electronics, high radiation environments. Now, achieving all of these 4 simultaneously using incumbent technologies is extremely challenging, and system designers are often faced with tough trade-offs. And so what are the incumbents? Well, they can be split broadly into 2 families. There are switching regulators. These are versatile. You can increase voltage as well as step down voltage, and generally do so with high efficiency. However, they require a lot of additional components to operate. And switching is also a fundamental source of electrical noise that you must deal with. And so that makes designing with switching regulators extremely challenging in small, space-constrained and noise-sensitive applications. Our technology is a high-efficiency, much smaller footprint alternative. And crucially, it doesn't use any switching. And so it eliminates that switching noise problem at its source. The other family are linear regulators. These are very simple devices and very low electrical noise, but you can only step down voltage, and that limits their usefulness. And if you need to step down anything other than a very small step, they're highly inefficient. And so our technology is a drop-in replacement for a linear regulator, but has much higher efficiency. That means under identical operating conditions, there's significantly less power dissipation. That means less heating and also improved reliability. And so the DC voltage regulator market is large and diverse, and most major semiconductor companies compete within it. Our dual-use technology is specifically addressing noise-sensitive and space-constrained applications in all sectors. Our beachhead market is focused on niche aerospace and defense and high-end commercial applications. And then beyond our beachhead, we're looking at other noise-sensitive and space-constrained applications in areas such as automotive and industrial IoT. And so since 2020, our company has raised over $3.5 million in non-dilutive grant funding to take our technology from a concept on paper through multiple rounds of prototyping to our mature commercial prototypes today. We've engaged with and shipped evaluation parts to multiple potential customers, and early next year a handful of devices are due to fly on the International Space Station to gain their first flight qualification. And so our team has over 25 years of experience in startup, university and national lab environments, and we've also worked with multiple advisors with strong technology commercialization backgrounds. And we're looking to raise a Series A round of roughly $4 million. About half of that we aim to raise through a federal cost matching scheme run by AF Ventures called TACFI, and that's available to Phase 2 SBIR awardees. With those funds, we're looking to expand our team and in-house a key part of our manufacturing process, and we'll be looking to propose for that early next year. And with that, Ken and I would be delighted to discuss in the session afterwards if anyone's interested in learning more. I'd also like to thank the George Washington University TCO for sponsoring our presentation pitch here today. Thank you for your attention.